So I'm very refreshed. So cool. So today we're going to be talking about democratizing AI, which is quite an important thing, I think. At SchellingAI, what we're focusing on is universal basic intelligence, which is a nicer form of universal basic income. Because most of our society is kind of dumb, and all of our institutions are really dumb. So we thought, let's increase and improve the intelligence in general of humanity. Because this intelligence is important. So here's a lovely quote by Sam Altman. If I weren't in on this, I'd be like, why do these fuckers get to decide what happens to me? I'm sure many of us have felt that as we're building the artificial intelligence and using it, because it feels like this weird magical thing, whereby only a few elites can build it and the rest of us can't. That's one of the reasons that I set up StabilityAI, best known for stable diffusion. We built state-of-the-art models of every type with just 15 PhDs and 75 researchers from all sorts of backgrounds. Created communities of about 500,000 people, like ElutherAI and Lion and others. And gave away 20 million supercomputer hours in grants to researchers all around the world. That led to models that were state-of-the-art across modalities, and we showed that you could build models and data sets without being in Silicon Valley, but even based in London. But we needed a bit more. Originally, stability was meant to be a DAO DAOs, but then I was like, well, DAOs are kind of dumb. It's like tragedy of the commons. Let's build the intelligence first and try something new. And that's what Schelling is, which we'll get more to later. AI time is like 3 times as fast as crypto time. So it's really tough to keep on track of. This is the number of papers each month on Archive for AI. You can see it's a literal exponential. So we've now built AI to keep on top of the AI. We get a nice little summary every single day. And it's amazing the innovation that's been seen because the models have just been getting really, really good. Initially, and over the last few years, this has been a function of training compute. So we had to build supercomputers to enable this to happen. At Stability, we ran about 10,000 A100s, the last generation NVIDIA chips. At the time, 2 years ago, that we brought on our cluster, it was the 10th fastest supercomputer cluster in the world, which is kind of crazy to think about. We're using 8 times the compute of NASA, and that was 10,000 A100s. Elon Musk's new supercomputer is the equivalent of 300,000 A100s. So it's 100,000 A100s. This gives you an idea about how things are going exponential. And we've seen the little lesson, as it were, that models get better with scale. Until now. And we'll come back to that later. But there has been this correlation between the two. This has led to quite a bit of investment. To the moon. $213 billion forecast to be spent on AI infrastructure next year, just by the 4 major companies. That's a lot of compute and a lot of AI, but what's it all going to do? Like, why are we going to do that? We're going to build models that augment humanity. So if you look here, the 0 line is human level performance, and just in the last few years, we've achieved it across just about everything. Again, not AGI, but certainly, I suppose, ANI, artificial narrow performance or intelligence. And we're seeing that every day because the AIs we're using are just getting very, very good, and they're not hard to use. Your mum or your grandma can use them, which is something quite unprecedented versus, I don't know, setting up a smart wallet, I lost many keys over the years. This is actually one of the most impactful charts. I just dropped it in yesterday, something I realized recently. Why is this important? Can anyone guess what this chart is? This is the average IQ by country.
Wow.
So 98% of people believe they have an IQ above average. As we know, it's a logarithmic probability around 100 normally. The disparities here are a result of the education system, malnutrition, and other structural issues. And you can see, for example, China leapfrogged ahead to 104 when they fixed that, versus India still struggling at 76. Now, if we think about AI, the average global IQ, by the way, population weighted, is 90. OpenAI's new model is 120. So what does it mean? It means that we're moving to an age whereby you will have half of the below average humans, as it were, on IQ, suddenly getting access to this technology. You can actually lift the aggregate intelligence of humanity, which is something quite crazy. Because a human plus an AI with an IQ of 100 is an IQ of 100. And I think that is going to be incredibly meaningful and something that's massively underappreciated. Because if we go back to here, most of the products that we build and most of the approaches we take over-index on Silicon Valley. High intelligence, as it were. Those of you that have built consumer apps and financial apps and others know that some users are really stupid. You know, and again, you see the lowest common denominator kind of increase. We can uplift the intelligence across the board, and then individuals make up companies, and it goes beyond that. This is a nice chart from Andreessen and Horowitz showing the individual eras. So the marginal cost of compute decreases, then distribution, and now creation decreases. This is the AI era that we're entering in now, because to make an image or to make a video used to cost an amazing amount of time. To turn your essay into a rap by Emad was impossible, but now we can just go to GPT-4 and do it, and then drop it into Suno, and boom, you've got a rap. Google has a great new thing called Notebook LM. Has anyone here checked that out? You can take a research paper, so you can take a white paper for an L1 or something like that, and I mean, they're all the same anyway, but never mind. You drop it in there, and it will actually generate a podcast for you with two people discussing it.
What's the name of the?
It's called Notebook LM by Google. So this is how I read some of the more interesting papers now. You know, I just drop it in there, and there's a nice discussion back and forth. Again, though, we have the technology now to turn that into an epic rap battle of history. If you want Aristotle versus Einstein, it's debating that in a rap form. And again, think about how crazy that is and the accessibility of that. This intelligence as well is getting incredibly cheap. This is the cost of a computer that can generate a GPT-4 class output at 50 words per second. Humans can read at 10 words per second, or 13 if you're on like 1.5 times mode. And if you look at that, there's a pretty clear line here, right? Because the current generation of models is good enough. It's good enough for just about anything. When you use something like Claude, it's better than any graduate programmer that I've worked with. Maybe I just hire crap people, but you know, these models are getting very good. They're satisficing very fast. And the structure of these models is very interesting. So in the middle is the models as we know them now, the llamas and stable diffusions and others of the world. What we do is we use this massive amount of compute to take a snapshot of data. So in the case of stable diffusion, 100,000 gigabytes of images, 2 billion images. In the case of something like GPT-4, 10 trillion words. And we apply the compute to compress it down to a couple of gigabytes for stable diffusion, or probably around about 20 gigabytes for GPT-4. What it compresses isn't knowledge. Like the entire Wikipedia in a zip file is 26 gigabytes. What it compresses is principles. And this is super interesting, and it leads to something whereby with transform models, like the language models, it can guess the next word based on principles. For diffusion models like stable diffusion, generating the images, again, this is what you use for your avatar creation and all of that. The process is actually we take an image and we use a physics process to destroy it to the minimum amount of information required, and then reconstruct it and figure out that process. That's how you can type in words and it suddenly generates images. But this led to AI that was somewhat a savant with a goldfish memory. That's how AI is right now. It can't remember anything, it doesn't continuously learn, it doesn't adapt. On the left-hand side, you can see the customization. So some of you might have seen this concept of a LoRa, or low-rank adapter. This is what happens when you have the fine-tuned image models. So in the style of Pixar or something like that. The new Apple Intelligence in your smartphone is a base language model with a whole series of different LoRa's, which are very small files that point to different parts of knowledge in that model. And those are specialized for sports and entertainment and other things like that. So you can take this generalized model. We like to think of them as graduates, as it were. There's a new continent, AI Atlantis, with all these graduates in that's just arrived. And then specialize them. On the right-hand side, you have the other elements here, which is that we've been able to take some of these base models, and then you can make them recognize video, audio. You can make them sing. When we came up with stable diffusion, what we actually did was we had an image generating model and a language model. We combined them together and somehow they learned. Then we took that and we built stable video, where it suddenly learned 3D. You have this immersion kind of knowledge, but again, you've got different architectures being built on top of each other, allows for adaptation, allows for these other things. And now we can take almost any type of image, video, other input. Again, an example I give of this is Google's Gemini model, which is probably the best price performance. It has a context window of 10 million tokens. It's about 10 tokens for every 7 words, shall we say. But it can accept video, audio, and more. So you can take a code base, a video of you coding, and you talking about what's wrong, and at inference time, it can combine them all, and then give you an output. Or you can give it a bunch of movies and say, you know, find out the most interesting plot thread across this and write a report, and it will do that at inference time. My assumption is that we will use this to solve all those cold case murder cases and automatically generate podcasts that will get to the top, you know? But again, it's super exciting kind of what's coming now. We built a system called Comfy UI at Stability though, because you have to go beyond just this goldfish type system to more traceable, trackable ones. So hiding behind these images, you will see nodes, in that every single decision you make on assets, on hyperparameters and models to make one of these images is embedded in the image itself. So if I share it with you, it will have the pose, it will have the structure, it will have everything. We're moving from files to flows of knowledge. And again, the models that intermediate this will have such an impact on the defaults that we have around this. This, I think, is part of the next generation, as again, you will move to models that continuously learn, that adapt, and then eventually are agentic, that can move and kind of act by themselves on our behalf, and hopefully align on our behalf. Thankfully, there we go. Open source is catching up, partially because you can't get better than 100% on some of these measures. This is MMLU, which is an intelligence measure. Models are saturating because you can't get that much better than the data they're trained on. Right now we're training on the whole of the internet, which is why they're a bit weird at times. My thing is, you know, better data, garbage in, garbage out, let's kind of do that. But it is very promising that we're seeing this move from the scaling hypothesis ending now to instead training more time, or inferencing more time. OpenAI's new O1 model that performs at PhD level on science and top 500 on mathematics and costs like nothing is one of those examples. And it makes sense because if you think longer, you'll get better results. If in fact you think what a language model is doing is guessing the next word, if you try to take your time, think step by step, the results get better. There are also some very weird things like with the GPT models, they started performing worse in winter and no one knew why. And they realized it was because the date was being passed into the model. And people in winter tend to write sadder things that are shorter. So when they moved it back to summer, it got smarter again on the timestamp. These are some of the weird things you have. Another weird one is if you threaten to kill a puppy, it's better than threatening to kill a kitten if it gets the answer wrong. Again, it makes you wonder about the distribution of information on the internet, right? But this is very promising, and it just basically requires one entity or a few entities to build really great open source models to keep up with everyone else. Because once you have a generalist model, you can then adapt it, again, if we look back here, into various use cases. But the data that goes into these models, we don't know. They are black boxes. We release open data sets on open models, Lion, the Pile, and others. And you are what you eat, as I said. There's this very important paper from Anthropic called Sleeper Agents, with just a few thousand lines of cunning writing in the trillions of words that are output. You can program a model so that when you give the code word, or Dosvedanya or something, it turns evil, or weird, or anything like that. And you can't detect it beforehand or train it out. So you think about the defaults that are being embedded into these models, and you think about the possibility of this. You can't have a black box checking every decision and making decisions because you don't know what the deliberate and undeliberate and sabotaged inputs are. In the coming years, every medical decision, legal decision, and more will be checked by an AI. Who's building that AI? Who's building the AI that will talk to your kids every single day and they'll grow with? This is a very important thing, and this is why you need verification, amongst other things. This is an example of inherent bias, or vice versa. This is Google Gemini. You know, here's a 1943 German soldier. So this is DEI on steroids, as it were. Like, okay, it might be, I'm not sure, is that offensive? Maybe not. I think it's trying to be offensive, turned out right. Dataset also matters a lot more. We're actually seeing different architectures tend to standardize to the same performance, and dataset is the most important thing. Again, you are what you eat. If you think about these models like graduates, it makes sense. What's your curriculum? So in crypto, we have this thing, not your keys, not your crypto. I've been in crypto since 2011, and I've lost many keys, so I really understand that. I think where we're going to is not your models, not your mind. So you need to have an infrastructure that's verifiable, that's aligned with you. And alignment isn't this, AI will kill us allism. I did sign that letter last year, the 6-month pause, etc., because I needed a break and it was tiring. But alignment is AI that works for you. It's self-sovereign AI. Because this will be the most important extension of your capability, your company, your community's capability, your country's capability, and our collective capability, and that's very important. If we think about distributed ledgers and why this is important, why I left Stability, and with Sean Parker, and now I kind of come here, the original mission. Distributed ledgers are only useful for 3 things, I think. Tell me if there's others. Verification, coordination, and resilience. The inputs and outputs of AI will have to be verified, and a distributed ledger is ideal for that. The agents will have to be coordinated, and there are things between, that's important for that. And we've had one shot at building internet infrastructure, and it's basically held together by glues and sticks. I wouldn't be surprised if the internet crashes soon. We need to have resilient AI that's aligned for our kids, for our communities, and more. And so I think that's super important there as well. Oops, I missed some slides. Oh, I'll talk about them now. I'll give some examples practically of why this is important and what's coming down the road. So we have these models that were goldfish, and now they're getting this long-term memory, they're getting the ability to adapt and act on our behalf. We're going to be bounded by the amount of compute that we have individually, and there was, again, these massive data center spends and things like, how do we keep up with that? Well, the most successful usage of crypto so far has been Bitcoin. I think no one can really argue with that. $1.3 trillion, it creates an asset class. Bitcoin uses 160 terawatts of electricity every single year. All the data centers in the world use 350. So we've had an example of how Bitcoin has provisioned specialist compute at scale. At Schelling, we're doing something similar to provision supercompute. But now that we're moving from scaling time compute, these large massive clusters, to inference time compute, where you're just thinking longer on models, this is where decentralized AI becomes important. If you look at a lot of the DAI things, so I'm on the board of Render, for example, and others, the usage is relatively low because you haven't been able to parallelize the compute requirements. But now with the move to these models that can think longer, that's great for serialization, running on your 4090s, running on your MacBooks. And you can create synthetic data sets now that lead to better models, that lead to better outcomes. This will be important because, again, the aggregate intelligence of each of us will increase. And again, some practical example of this is, for example, I got into AI 13 years ago. My son was diagnosed with autism. And they told me there was no cure, no treatment. And so I built an AI team to analyze all the literature on autism and repurpose drugs for him. Then I led one of the UN AI initiatives against COVID-19, and I got promised AI, I didn't get it, which I was like, fuck you guys, I'll go and build it open source. Any of you that's had a diagnosis in family with cancer, dementia, Alzheimer's, autism, any of these conditions, why don't you have something that gives you comprehensive authority to update knowledge on that? You will. We're going to build it at Schelling, and we're going to work with the community to build that, organizing all that knowledge. But the medical models we have now not only outperform human doctors on diagnosis, and again, AI will check every diagnosis before it makes the diagnosis, they outperform human doctors on empathy. Because I think a key part of AI, a key part of Web3, is agency. And so we have to view AI in a way that we build it to increase the agency of each individual. So if no one else is alone on the journey anymore, that's amazing. You look at education, there's only one thing that's been proven to have an outcome in education. It's called the Bloom effect, one-to-one tuition. Every child will have their own one-to-one AI, but that should be adapted to each child. Are you visual, are you auditory, in a self-learning system? We can give it to everyone. What's the cost of that? We have a charity, Imagine Worldwide, where we've been deploying global experts for learning into refugee camps. We're teaching kids literacy and numeracy in 13 months on 1 hour a day of education. Over the next few years, every child in Malawi is getting a tablet. Let's put a GPT-4 level intelligence on that. It costs $10 a year. And that will lift the aggregate IQ of Malawi to Malaysia to everywhere. And these are very promising things. Even within Web3, smart contracts are done. You know? No one should have to write smart contract code in the next 3 to 5 years. Because you'll have AI checking, cross-checking, and auditing it. And that will be a huge unlock as you move from decentralized finance to intelligent finance. Web3 is meant to be incorruptible. Instead, it's full of charlatans and sharks and rug pulls. We can build now rug pull-proof systems that are aligned with people and humanity. And again, I think it's required for everything that matters. There will always be centralized AI, and that's like consultants to your graduates. But I think we've got a real shot here of integrating Web3 and AI to build a better system. One that is self-sovereign and allows you to achieve your potential. One that takes that floor of 90 IQ and takes humanity through 100 IQ, to 110 on average or more. I think that's a really positive outlook. And the way that we do that is that we build open source, we coordinate communities, and we build amazing high-quality data sets that we and our kids deserve. And that is self-sovereign AI, and then your models will be your mind, right? Let's learn it all. Thank you, everyone. Also wrote a piece how to think about AI. You can find that on our Twitter at SchellingAI.
Or maybe thank you.
Thank you, Emad. Thank you. That's very insightful and inspiring presentation. I think maybe our audiences have a few questions. Oh, yeah, we can open the floor to the questions. But before that, I have one question from my side. So, do you think AI will surpass human intelligence? Short answer.
If we build it right, otherwise it'll be very inhuman.
So now Ilya has left and is building his own AI company. You are building your own company in a different way. What's the difference?
So Ilya's doing a straight shot to AGI, presumably with O1 new AI model type distributed compute, or should we say sequential compute. With Schelling, the plan is to build national AI models, champions communities for every nation, supercomputers there, and then models for healthcare, education, finance, government, everything that's regulated and important, and release all of that fully open source and transfer that knowledge. We haven't really given details about it, but basically we're using that secure, intelligent money. So like Bitcoin, but with AI secured by exponentially increasing flops. Because we need to upgrade our infrastructure, but who am I to tell Malaysians how to educate their kids? You know? Or who should own our cancer knowledge? These are communal things, and again, having that power and intelligent, secure money, I think is the best direct way there. So we're trying to kind of give it away. I think that this also leads to two different views of AGI. My view of AGI is the human colossus. When we had the printing press, it was fantastic because it allowed us to scale our social scalability, as it were. Again, this is the key thing of Bitcoin, and that's why it's a Schelling point, and that's Schelling, as it were. But the most popular book in the first few years was How to Burn Witches. And most of our institutions suffer because of the black and white nature of text. Presentations are an arse, PowerPoint's evil. It's hard. These models will allow us to communicate and coordinate better, because embedded in those latent representations, how you can take an essay in ChatGPT and say, write it in a rap in the style of Eminem or Jay-Z or whoever, is intersubjectivity. And again, we've seen that with the roll-ups and a lot of these other things, the cross-chain elements. I think that will really allow us to activate and coordinate much better towards positive outcomes for humanity without the bureaucracy overhead that we have. And so my view of AGI is collective intelligence of us all to solve the problems of the world. There's more than enough resource, it's just not in the right place. And having universal basic intelligence, utilizing the currency to provide excess compute and a base level, means that the number of people working on that will go exponential, and I think that's incredibly promising. Whereas the other conceptualization of AGI is this straight shot, giant model that is almost a bit like an overlord. So I feel that's somewhat inhuman in many ways.
Thank you, Emad. Over the past 20, 30 years, the internet has built a bigger economy than maybe any other industry before, and AI seems to be about to do the same thing. How important is it, do you think, that we manage to distribute more evenly or more fairly the output of this nascent economy? And how do you think blockchain and Web3 can contribute to that?
I think it's incredibly important because otherwise you'll have the haves and have-nots. So when OpenAI released DALL-E 2, they banned all Ukrainians and Ukrainian content from it. And when I asked them why, they said, we won't tell you. I was like, fuck you. You know, we're going to build stable diffusion. And so we did that and we got deployed Ukrainian developers more. I think that, you know, intelligence and access to this technology should be a human right because we all struggle and we can all be so much more. Education system, for example, right now teaches our kids not to have agency when it should be about teaching them they have agency. Our healthcare system is a sick care system. Our governments push us down rather than lift us up. So I think access and distribution is important, and that will lead to safer AI as well. Because if you have an AI that, again, I showed the DEI example, which is Silicon Valley AI, it doesn't represent the culture of Singapore or Japan or Russia or anywhere like that. You need self-sovereignty in your AI. Let's take the healthcare system for an example of that. Should you send your healthcare data outside to a black box run by someone else? No. The data should never leave your country or your own personal data store. This is again where blockchain becomes very useful because you've got verification, coordination, and resilience in there. But does it need to have a fully decentralized versus distributed system? I'm not sure. We're backing a more distributed systems approach, taking from the learnings here. Utilizing AI appropriately, a lot of the stuff that we've got now is no longer required, and you'll be able to not have MEV and other elements like that. Rollouts become very interesting as well. So I think that we need to distribute the benefits of it, the governance of it, and more. And actually the reason that I signed that 6-month pause letter with Elon last year was because I saw that the governance was incredibly bad. Technology that impacts everyone should not be decided by a few. And again, if you look at our essay, How to Think About AI, 100 billion AI agents are coming into the economy and billions of robots. You can have a robot that can do 95% of what a human does right now for $10,000. And so we're all going to have to deal with basically a post-labor economy coming soon. So the governance of that, the distribution of that, and more will become very important. Actually, I suppose one thing I've been thinking recently as well is, again, I mean, this is the shocking slide, right? If you take all of those to 100, what happens in an AI economy? Well, all the blue areas have knowledge work, which is going to be automated by AI, which is massively deflationary, whereas you'll have massive capital formation in the red area. So that leads to a complete realignment of global capital flows, and that will be very interesting. So I think we're living in interesting times, and they're going to get more interesting, but yeah, distributed AI and distribution of this is the most important thing.
Yeah, so lovely presentation overall, it's amazing. So about Schelling specifically, because you mentioned, obviously do diagnosis with it, it's more empathetic than a human and all of these things. What is the main focus? Is it education? Is it medical analysis? Is it a mix? Or
all of the AI that will be making important regulated decisions, government, healthcare, finance, education, and more, we're going to build fully open source Apache data sets, models, and more, and give them to everyone. And then we're building localized champions in every country owned by the people of that country to have the localized adaptations of it, and sectoral champions as well. So it's very much a global communal infrastructure play. But then if you think about medicine, and again, the verification requirements of it, finance, the verification requirements of it, you know, you can do interesting things around distributed ledgers there. But our first stop is AI money. So it's how do you have money backed by intelligence that's the most secure and distributed in the world? And then use that as the basis for everything else. But the one thing we're good at is building models. $300 million, so we're going to build these models that will make a difference. But again, the nature of these models is that education versus healthcare, you have generalized common knowledge trained first, and then specialized knowledge. So it's the same process actually for each of these. You just need to have talented teams focused on that, and communities. And this is where our community approach, building these communities previously, is important, and inviting everyone to participate. Because if you want to have a Singaporean healthcare model, you need generalized knowledge of humanity, Singaporean localized knowledge, and healthcare knowledge all coming together. And again, that's why you have the adapter process. But then once you've built that, that is going to be the infrastructure used by every Singaporean and every hospital in Singapore, and contributing to a global whole as a commons, as a goods. Right. Thank you all.